Question 22 of page 376 from Active Maths 4, Book 2. Right, we're asked to find the length of x. Okay, so here I have a regular hexagon, hexagon. So that means all sides are the same. So that means this side and this side are 12 centimeters as well. All right, so I'm just going to draw this triangle out. So this is 12, and this is x. Okay, so we're looking for a third side when given two sides. Now it's not a right angle triangle, so I can't use Pythagoras, can't use SOHCAHTOA. Can I use sine rule? Can I use cosine rule? So we have to check, are we able to work out what any of the angles are on this? Well, we should be able to, okay? So if you look here, if we want to find the angles in a hexagon, start at a point. Now they've already kind of done a dotted line here for us, so that's one triangle. Right, I'm going to draw lines to every vertex of this shape. So I'm going to draw a line out here. So that's a second triangle. I'm going to draw a line out here. That's a third triangle, and that's a fourth triangle. Okay. You know that the angle sum of a triangle is 180. So this is going to be 180 times 4. Okay, so the angles in a hexagon total to 180 multiplied by 4, which is 720 degrees. Now, they are all the same angle, and there's 6 of them. So if we divide 720 by 6, you will then get 120 degrees. So now we can work out that this angle here is 120 degrees. Right, so I can put that in here. Now, two ways of doing this. Because this is an isosceles triangle, you know that at 160 plus this makes 180, and these guys have to be the same. So what could they be? So they have to total 60, so each of these is 30 each. So that's 30 degrees, and that's 30 degrees. So now you could use the sine rule, but if you preferred, you could also use the cosine rule. I'll just go with the sine rule for now. So you pick a side, we're looking for x, we're definitely going to choose that side, and then these are the same anyway. So I'm going to say x over, or we'll actually write out the rule first. So a over sine a equals b over sine b. Now I've put a over sine a because I'm looking for a side. If I was looking for an angle, I'd say sine a over a equals sine b over b. Alright, so in this case, a is x. So just write x over sine of 120 is equal to 12 over sine of 30. So that means x is going to be 12 multiplied by sine of 120 all over sine of 30. So let's just cross multiplying there. And you're going to get 12 root 3 is your answer. 12 root 3, and make sure you put in your units. And it's centimeters, so we'll make sure we put centimeters in there. Now again, you could have used cos rule. You could have said x squared equals 12 squared plus 12 squared minus 2 times 12 times 12 cos 120, and then work from there. That would have been perfect to do as well. Okay, that's part 1. Part 2 of the question says calculate the area of the hexagon. So part 2, we're asked to find the area of the hexagon. Okay, so if you look, how can we find the area of this? Well, this here is a triangle where I have most of the measurements. Okay, and we have another triangle here. So I'm going to split this, a triangle, a rectangle, and a triangle. All right, so I'm going to find the area of the triangle first. So the area of the triangle. So look again at what we have. We have 12, we have 12, we have that now, but I'm still not going to use it. 120 there. Now, you could go in and use Pythagoras if you wanted to find the height of that using your x here. You could have that and find the height there and do half the base times perpendicular height. Or because I have an angle and I have the two sides, we can also do the half AB sine C. So I'm just going to go with that. So the area of triangle is half AB sine C. So that is half times 12 times 12 sine of 120. So that is 36 root 3. Okay, so that's 36 root 3 centimeters squared. Now that's one triangle, okay? So I've got two of those, they're the exact same. So I'm going to times that by 2 now. Okay, so the triangle, so the area is going to be triangle plus the other triangle plus the rectangle. Okay, so the triangle, so 36 root 3 plus 36 root 3 plus, how do you find the area of a rectangle? Well, it's length times width. So in this case, we found that in part 1, so that's 12 root 3 times 12. Okay, so that's 12 times the 12 root 3. When you add all those up together then, you are going to get 216 root 3 centimeters squared. Okay, so that is your area. All right, then part 3 of the question says when the hexagon is enlarged by a scale factor k, its area is 1944 root 3. Okay, so part 3. When it's enlarged, its area is 1944 root 3 centimeters squared. That's the enlarged, that's the big area, okay? Now, remember scale factor, we're going to put the big over the small. So here we're going to say, sorry, big area over the small area. So they've given us the big area and we've already worked out the small area. So let's pop those into our calculator. So 1944 root 3 all over 216 root 3, and you're getting 9. Okay, so we have a scale factor of 9 for our area. Now if the area scale factor is 9 and we want just a length scale factor, so they want to know what the scale factor is for the perpendicular height, okay, because it's a length, we're going to square root it. So that's the area scale factor. So to go from an area scale factor to a length square factor, we root it. So scale factor of length is going to be root 9, which is 3. So the scale factor is 3. Now we know that the height was x, so we found that again, that was 12 root 3 here, and that's the small one. We want to know what the height is of the big one that we're talking about. So that means we're just going to say x multiplied by the scale factor of 3. So that's giving you 12 root 3 times 3, which is going to give you 36 root 3. That is the height of the larger hexagon.